Sour gas is incredibly prevalent in several key drilling markets around the world. Areas where this H2S-infused natural gas is prolific include the Middle East, Canada, China, and Russia. Sour gas presents numerous challenges to safety and to the integrity of steel components, notably drill pipe. This virtual panel discussion, graciously sponsored by Vallourec, is entitled 2004 to 2014, a decade of drill pipe grades and industry standards evolution to address increasing H2S challenges. Sour service drill pipe has been used for more than a decade in Canada, as well as in other regions. Our guests today will outline the challenge and review several case histories in the Middle East and Asia, as well as recap different practices for material selection and qualification guidelines. Hi, I'm Mike Kilalia with IEDC and drillingcontractor.org. I'll briefly introduce our panelists by name, job title, and company, leaving their full bios for later. Our first speaker is Vincent Flores, Global Product Line Manager for Offshore and Sour Service Drilling Products for Vallourec. Vincent will set the stage for us and provide an overview of sour gas and its impact on drill pipe. Following Vincent, we'll hear from Ian McLeod, Country Manager for Petrostem, a leading global oil field equipment rental company. Ian is based in Erbil, Iraq, from which he manages Petrostem's Kurdistan operations. Ian will discuss some experience from the field with sour service drill pipe. Please take a moment during the webcast or afterward to post questions for the panel. While we can't answer questions in real time, the panelists will prepare responses which will be posted on this webpage. We'll shoot you an email when the responses are live. Vincent obtained a Master in Materials Science and Engineering in 2006 from the National Institute of Applied Sciences in Lyon, France. He then worked for 3 years with the steelmaking group ArcelorMittal as research engineer in stainless steel grades development. During this time, Vincent worked in both Brazil and France. In 2009, he joined the Drilling Products Division of Vallourec as Marketing and Technical Support Manager for the Middle East, located in Dubai. And then in 2012, Vincent moved to Houston, Texas, also with Vallourec, to assume the position of Global Product Line Manager for Offshore and Sour Service Drilling Products. Vincent is an SBE member, has served on several SBE conference and workshop program committees. He is also a contributor to IRP Volume 1, 2014, and ISO 11961 standards revisions. Vincent, the floor is yours.
Thanks, Mike, for the introduction. So first of all, let's describe what is a sour service environment. So basically, it's a well that contains H2S. The H2S comes from the decomposition of organic materials. There are several origins and complex processes behind it, but usually a well that contains a high percentage of H2S, that origin would come from the same as the oil or the gas that will be in that same reservoir. There are several consequences dealing with a sour service environment or a sour gas well. The first one is the HSE risk. As a matter of fact, the H2S is hazardous to any living organism, so it's a major concern for any recontractor or any operating company that would deal with such a project. The recrew would be at risk, but also all the communities that could live around the well. H2S actually also interacts with steel. Any kind of steel tubular can be affected with H2S through a phenomenon that is called surface stress cracking, which I'm going to refer to SSC to make it shorter. And basically that failure can lead to the loss of the whole drill string, the BHA, but also can have consequences on the casing and tubing material. Of course, consequences of such failures would involve fishing jobs, large OPEX, and of course, non-productive time. There are cases, I've seen cases myself where it took more than 40 days to retrieve the BHA and to have a control of the well. So you can see in the picture of the slide an example of a SSC failure. It's a very typical facet of failure where you have a 45-degree angle compared to the stress direction. So in case of a drill pipe, you will have a 45-degree angle compared to the vertical direction. So the particularity of the failure and the problem linked to H2S is that it will occur below the tensile capacity of the pipe. So you cannot really predict it. You cannot see any deformation of the material. It's very different from any other kind of failure mechanism you can have on drill pipe. So it's unpredictable. and it's very catastrophic because you would basically have the material behaving as a brittle material, such as glass if you throw a stone on a window. Without entering into too many details, this is how the mechanism can occur. You need to have actually the combination of unfavorable factors to have this kind of failure occurring. First of all, you need to have acid conditions, the presence of water, and of course H2S in a significant amount, so you can have this corrosion mechanism starting. So of course, drill pipe are being used in mud environment, so it's a controlled environment. There is no reason why you would have H2S, acid, low pH, because usually the mud has a pH above 7. So the only reason why, or the only condition that would be very unfavorable would be if you lose control of your well. If there is a kick, if there are fluids entering the annulus, if you drill under balance, if you use MPD, then yes, there could be basically all those factors all together, and then the mechanism will start. So typically, the H2S will decompose at the surface of the steel, and you will have a hydrogen embrittlement of the material. So it's very common to see pipes going out of the well after being exposed to H2S having a very dark green or black color. And this is actually due to the first corrosion mechanism that occurs at the surface of the steel. And then the hydrogen will basically be present inside the steel matrix. And if you pull tension on the material, then there could be a crack initiation that could propagate in a brittle manner. And again, with a 45-degree angle, typically. There are several escalation factors. Not all the grades will be susceptible the same way. The higher the yield strength of the material, the higher the risk of having a failure. The material is actually more brittle if the minimum yield strength is higher. So the way the industry is actually qualifying sour surface drill pipe in order to be used in a sour well, or potentially in a well where they could be exposed to H2S, we actually use one of the NACE standard method, which is the NACE TM0177, which has been put together in 2005. And that norm actually defines 4 testing methods. We actually use only one for drill pipe because it's a tensile test and it's relevant to the stresses applied to a drill pipe during the drilling operations. The test will last 720 hours, which is basically almost a month of testing a sample that you would take out of a drill pipe body or the tool joint or any other area on the pipe you would like to test. 1 month of testing under a specific content of H2S and a specific pressure. And the test is actually not quantitative. It's not going to tell you, well, you can use this pipe for 5,000 rotating hours in a sour well. It's basically a go, no-go test. So whether the sample passed the test, then we consider that the drill pipe is okay to be used. If the sample fails, then there will be corrective actions that would have to be taken. So for example, another heat treatment, or eventually completely scrap the batch and having to remanufacture the drill pipe by itself. This is an example. There are several pictures displayed on the PowerPoint, which shows you the testing. So you can see the sample is machined. It looks like a tensile test sample actually, and that would be placed into a loading cell, and then we will apply a force, a load that would be always a percentage of the specified minimum yield strength of the steel. For example, if you have a grade with a 105 KSI minimum yield strength, we would apply a load that would be 70, 80, 85%, depending on the requirements. Vallourec has several labs for which we can do the testing in-house, either for research purposes or for actual orders purposes. But there are a lot of certified labs around the world that can actually perform this kind of testing. The NACE Material Recommendation 0175 or the ISO 15156 is another standard that is very used in the industry as far as sour service. It is not directly applicable to drill pipe because they are considered in that norm to be used in a control environment, which is the mud. It's basically a standard that is used for other tubulars. Nevertheless, the interesting part of it is that it would help to segment the susceptibility of H2S toward steel tubular depending on the partial pressure of H2S and the pH. The pH basically represents the acidity of the environment. Mm-hmm. The partial pressure would be the multiplication of the content by the pressure. That means that you can have actually the same severity on a tube if you use content that is pretty low but a HPHT well, or a high content of H2S in a well that would have a pretty standard pressure. Mm-hmm. So it's a way actually to be able to segment, project by project, what could be the risk towards tubulars. Material selection for H2S resistant drill pipe is actually very challenging for the contractors and the operators. The main reason is there is no international standard that would actually provide guideline and material requirements for such projects. So today the API 5DP and the ISO 11961 are the two international standards that govern the material requirements for drill pipe, non-sour. But some initiatives at the regional level have been actually put together since a long time, since a decade. So the most famous one, and the ones that started in 2004, is the IRP. The IRP stands for Industry Recommended Practices. It's a volume. There's 21 volumes, I believe, and the volume 1 and the volume 6 are dedicated to drilling in critical sour environments. So originally it's from Canada, and it's widely used in Canada, but it's also used in different other regions of the world as of today. Vallourec has been producing the first IRP drill pipe in 2007 for the Sichuan Basin in China, for example. There are also several other regional initiatives. Some of them are in China. But Russia is a good example. They actually have a certifying lab called Vinigas that would basically give you a proper test for qualification to use products in sour wells in Russia, or the ones that are actually operated by Gazprom. So we actually passed this qualification in 2009, and we had our first commercial order in Russia using this standard in 2010. So we are today in 2014, and those pipes have been used for a decade. So IRP drill pipe have been used in several regions of the world, not only in North America, also in the Middle East, very widely, partly in North Africa, Europe, Russia. And so it's been quite a successful use because there were actually, to our knowledge, absolutely no failure that has been reported. But you will see that there are still some new challenges upcoming for which there is a need to have actually more stringent norms as of today. One of the main reasons is, and it's not only true for sour environment, I think the industry is pushing every limit further, and especially with the increased demand for domestic gas in some regions of the world. There are projects that are being drilled in harsher and harsher environments. So first of all, wells that were, or projects that were not economical before due to the very high content of H2S, we have to imagine that it's not only an HSE concern and a drilling concern, you also have to deal with the downstream process, H2S as a byproduct, or sulfur as a byproduct. And so it's very difficult for operators today to have those projects being economical. But the trend is that wells with higher and higher content of H2S, and contents that we would not even believe possible to deal with 10 years ago, are actually being explored and even developed as we speak. Also, there is the emerging trend of having underbalance drilling and managed pressure drilling, and this can be applied also to sour wells. It's quite risky, of course, because you would have H2S in contact with the tubulars, and you will also have to flare, so there's some environmental impact behind it, but it's also practices that we have seen emerging today. HSE, anyway, is a major concern, will remain a major concern, and so there is clearly now a real push for all the operating companies, and some actually NOCs, to have more stringent regulations and specifications on the tubulars when it comes to a sour gas project. A bunch of examples of very highly sour fields that are being export developed today. In the Middle East, you have the example of the Shrek field in Saudi Arabia in the MT quarter, which has H2S level above 30%. the Shah and the Bab fields in Abu Dhabi as well that have H2S content above 24%. And other fields that, so we are going to talk about Kurdistan today. Kurdistan is a region in North Iraq where H2S values can go up to 36%. So there are also other technical challenges when we are drilling those wells because not only the H2S content is higher, but also the well profiles are more and more complex. It's not uncommon now to drill very long horizontal sections having deviated wells or very deep reservoirs, and basically you need to have high strength steel materials to be able to drill those wells. It is very detrimental and more risky to use a high grade in those environments. So there is a lot of, I would say, development to be done from the manufacturer side to be able to meet those upcoming challenges. One last comment on this. A drill pipe is a product which is a tube welded to a tool joint by a process called friction welding. And any industry standard, including the IRP, is considering both the tool joint and the pipe body separately for the NACE testing. And we do believe today that there is a need to also consider the weld and any other area that was not really tested before. You can't just consider separately bits and pieces. The integrity of the entire drill pipe has to be taken into account. What is a sour surface grade? Basically, it's the combination of a specific chemistry and a specific heat treatment process. So we have also a lot of additional controls to be done during the steel making operations. This, what we call the steel cleanliness, which is the level of inclusion, the size of the inclusion in the material matters. If the steel is very clean, there is a lower risk of having a crack initiation in that particular area around the inclusions. So we have some specific steelmaking processes that are much longer, require more time, more complex than for other types of grades. There are also some chemistries, are always proprietary, that are being used. And heat treatments, of course, the quenching and tempering process for both the tool joint, the weld, the pipe body is very important and will not be the same as any standard drill pipe. In some cases, there could actually be several quenching and tempering processes made on some part of the product to basically reach the performance we are looking for and eventually pass the NACE test. As a conclusion, Vallourec has been actually supplying sour surface grades for decades, but we have the possibility to have integrated mills so we can deal from the steel making to the finishing of the pipe and work on these different steps to provide reliable products. We have in-house R&D and NACE testing facilities. There are today several manufacturers on the market that can provide IRP grades, and this for several years. So there is I would say, in general, a huge improvement in the quality of the products in order to meet the market requirements globally speaking. And also, it is very important to remain very active from a normative standpoint. So we are, of course, on board of the NACE committee, try to be on top of all the SP, IADC, boards, conferences that would deal with it, and more recently, on board of some ISO organization to revise some of the existing norms and provide a little bit more guidelines to all the users of surface drill pipe in the industry.
Thank you very much for an informative presentation, Vincent. And I've got to say, anything that increases demand and interest in natural gas is a good thing in our book. So that's great. But let me ask you, if I may, without compromising any proprietary information, can you give us some guidance or elaborate more on anti-H2S chemistry and pipe manufacturing, Vincent?
Basically, we have to remind that a sour surface drill pipe or drill pipe in general has to be cost effective. So we are not dealing here with CRA material or stainless steel or very highly alloyed materials, for which it could be the case for the casing tubing, mostly the tubing. Nevertheless, basically the strategy is to microalloy the steel. So there are some elements that we would use. So an example would be titanium, niobium, molybdenum. Those elements will help to build refined microstructure and to have basically a better resistance to the crack propagation and the crack initiation. And this is, I would say, in general what any manufacturer would do, but of course it's our own recipe on how to, what component and what percentage or ppm in some cases, and how to heat treat it in a way that it's actually providing a good microstructure. But the common background for everyone is also to try to lower as much as possible all the poisonous elements that are well known, so that's sulfur, phosphorus in the steel. And I think this is pretty much the basics of having a sour surface draw pipe, is to lower also those elements to the maximum.
Thanks a lot for that information and for a very informative presentation. I learned a lot about sour service here. And as Vincent alluded to, Kurdistan in northern Iraq has a lot of H2S prone natural gas. And our next speaker is addressing us from that part of the world. Ian McLeod manages operations in Kurdistan for Petrostem. His career kicked off in Aberdeen in 1989 with Smith International, where he focused on inspection and repair requirements for North Sea drilling contractors. He worked his way up through the company into the manufacturing side, where he was tasked with promoting the company's European business. In 2010, Ian had the opportunity to move into the rental tool business, serving in the UK with Premier Oilfield Rentals and with Weatherford. In early 2013, he joined Petrostem as their country manager for Kurdistan, based in Erbil, Iraq, from which he manages that company's operations for Petrostem. Ian's a family man with two very active young children and an ardent fan of the Aberdeen Football Club, as well as being an enthusiastic golfer, which, Ian, that doesn't always equate to being a good golfer. From 2011 to 2013, Ian also sat as vice chairman for the associate membership of the IADC North Sea chapter. Ian, the floor is yours.
Thank you, Mike. Good morning, ladies and gentlemen, and greetings from Iraq. I'll give a brief presentation today on the sour service environments and the challenges we face whilst operating within the region. A brief history on Kurdistan. The extraction of oil and gas reserves started in 2011, which was mainly exploration. There are currently 21 operators working within the region, either headquartered from Erbil or Sulaymaniyah in the south. With 45 billion barrels of estimated reserves, the Kurdistan region is poised to become a key part of Iraq's renaissance and a major player in the world oil markets. As exploration continues, the region is shifting to a development phase. Oil production increased from 75,000 barrels in February 2011 to 200,000 barrels today. The target is to reach 1 million barrels daily production by 2015. There are many challenges we face operating in Kurdistan. Politically aside, it's one of the most critical sour regions in the world, with high concentrations of H2S up to 30% and above. There have been several incidents over the period of time with drill string failures due to H2S, and on occasion the wells can take more than a year to drill. Two major blowouts occurred in 2010 due to drill pipe failures under the presence of H2S. The H2S failure in the client's exploration well was using G105 drill pipe. The failure ended up at the top of the string, and the root cause was defined as sulfide stress cracking. You can clearly see what happens when the improper grade is selected on the drill pipe. Thanks to a benchmark with other highly sour regions of the world, a selection of drill pipe grades and double shoulder connections orientated towards IRP Volume 1 products. In-house NACE testing is performed in all the drill pipe, and Petrostem have progressively ramped up its inventory of drill pipe and accessories to meet the specification and also the challenges faced by our clients. There have been several workshops organised by both Petrostem and Valrec within the region, and operators, drilling contractors and the KRG's Ministry of Natural Resources have been in attendance. Here we've got an IRP sour service drill pipe. Petrostem has a number of sour service drill pipe strings and accessories working within the KRG region to support both operator and drilling contractors alike. Here we can see the basic composition of tool joint and tube sections on our sour service drill pipe, manufactured in accordance with IRP 1.8. Back in 2011, a client of ours was the first operator to use the VM105SS drill pipe in Kurdistan. Over 5,000 metres of pipe was used in the H2S well, and no SSC failures were reported throughout the year's drilling campaign. Currently, the large majority of rigs drilling exploration wells in Kurdistan have been equipped with sour service drill pipe, and this has ensured safe operations for more than 3 years. The remaining challenges we have are non-H2S related corrosion. Acid injection wells when stuck pipe, CO2 corrosion. Acid injection must basically be avoided when using any steel drill pipe. Well, thank you very much for your time today, and I hope you have understood my Scottish English language, and bid you farewell. Thank you.
Thanks, Ian. Ian, what growth trends do you see in H2S wells in Kurdistan?
For sure there will be growth in the sour wells in Kurdistan, as with the majority of carbonate wells in the Middle East where there's a high prevalence of H2S. Historically, these fields were uneconomic, but with the advent of modern technology and a higher price of oil, they are now being exploited, so proportionally, they are on the increase. By 2019, the Kurdistan region is aiming to produce 2 million barrels daily and envision the presence of a fully functioning oil and gas industry exporting to the world markets.
Vincent, can you elaborate on that from a global perspective?
Yeah, I think Kurdistan is a good example of a region that is basically developing around H2S projects, but it's clearly something we are seeing in different parts of the world. The main reason is the demand for domestic gas. So the Middle East has been pretty active in developing several wells, and including with complex well profiles. There were a lot of technological challenges here. North America is also continuing to develop their sour projects. Historically, they've been pioneers in that respect. And we are seeing also in Asia several basins for which highly sour gas reservoirs are being developed. It's definitely a growing trend. I think those projects, as long as they can remain economical and as long as it's safe for the communities around the wells, there will definitely be more and more of those sour gas wells being developed in the future. Yeah.
Sure. Thanks. Yes, safety is a preeminent concern with all drilling operations for us at IDC and Drilling Contractor, and so we want to ensure that not only is our drill pipe safe, but also our people are out of harm's way. Well, it's really exciting to see that such a promising future is in store potentially for H2S gas around the world, especially in some emerging areas like China and Iraq. Vincent, let me ask you, what innovations do you see coming down the pipe, just from your standpoint of drill pipe, sour service drill pipe, that will help improve efficiencies and safety and meet demand moving forward in the future?
Well, I believe, if we want to guarantee safe operations and integrity of the entire drill string, one of the major areas of innovation we are working on today is to provide toughest NACE testing on the products. So, if the severity of the sour wells is increasing, we have to have products that would resist to higher pressures, higher loadings, contents of H2S. Like I said earlier, we are working also on other areas of the drill pipe that can be at risk, such as the weld. Beyond that, we will need to address the problem of the high strength steel. Today on the market, there are grades up to 120 KSI as a minimum yield strength, and from a non-sour perspective, we have 165. So there is still a lot of room to cover in order to provide to the market some high strength steel that could actually drill those wells efficiently and still having a very good performances in terms of SSC resistance. And I think, there is also a real need today in the industry to have maybe some common work between IOCs, contractors. We need to have a better understanding of the normative environments and provide a little bit more guidelines, maybe segmented by severity of projects. Because this is also something that is not real innovation, but is really lacking, and that could be really a problem for some regions of the world or companies that are not that much aware of what's going on and how to address problems.
Thanks, Vincent.
Welcome.
And thank you, Ian. That's about all the time we have. Again, thanks to our panelists for their very useful presentations, and thanks again to Valorec for graciously sponsoring this virtual panel discussion. Remember, please submit any questions you may have through the website, and we will review them and provide answers and shoot out an email when our answers are available. Also, remember this virtual panel discussion will be posted on the website for the next year, so feel free to return at any time and tell your colleagues. On behalf of drillingcontractor.org, thanks for tuning into this event. Please be safe and keep turning to the right. I'm Mike Kilalia. We'll see you next time. Bye.